Okay, so in this particular booklet, we're going to talk about lesson 1, which is working with data. So using lists, tables, and then eventually graphing. So lists, tables, and graphs. So our goal is to organize our data, organize our information. Lists, tables, and graphs are often used to organize and communicate information. So there's a lot of, probably you see graphs. What does a graph mean? What does it do? It really gives you a visual representation of information or data. So in this lesson, we will practice some of the skills involved in working with data. Data are the things that were collected, information that got collected. Using the list, tables, and graphs. So what does it mean by data? Data are information, facts or information used usually to calculate, analyze, or to plan something. So gathering of information. So the method we choose to organize and communicate data depends on the type of data that we have and the amount of data that we have. And also who reads it, who's your audience, who will interpret the data. If we want to communicate a small amount of information, okay, if it's not a lot of information, then it makes sense to just list it, right? It makes sense to just list. It is the simplest method to use. For example, listing the ages in your family members. So in your family, there's probably 3, 4, maybe 5 or 6 people. It's easy to say list. Oh yeah, the age of the people in my family are 7, 9, 42. That's my family. Okay, so that's easy. Making a grocery list, because it's a small amount of information. You could do it as a list. Listing your assignments and due dates, those could be done as a list. So this is also a data or information that could be just created and expressed as a list. So math test would be this, this, and this. It's not that bad, right? It's not a lot of information. But then most of the data that we're going to be talking about or dealing with. Hello?
I am sorry for the interruption. Do you have Sadi?
Sadi? Yes, I do.
Sadi P?
Yeah.
Okay, could you send it down to the office, please?
Office? Yeah.
Thank you.
Oh, yeah, he's coming down now.
Okay.
Yeah. I know. If I get called down to the office, I get this too. What did I do? Okay. Now, if we have a lot of data, and that's basically what it is. If we have a lot of data, we could actually, it's hard to write it as a list. It's hard to write it as just listing everything. So we have to somehow find a way to represent our data or to convey our data. And one way is that of a table. Okay, you probably have seen a table before. It would be like this, right? So it's a nice way to organize the data. The table on the right shows the age information for a group of 416 students. So can you imagine figuring out the age of 416 students? And it's a long list, right? It's a long list, a lot of information. But if we could arrange it or organize it in this way, so if you look at this information says the age on one column, and then the other one is number of students in the other column. So it says here 19 to 23 years old, how many students? 55, right? 24 to 28 students, how many are in that category? 65. Okay? And so on. So it's nice and organized in this manner. So on top of that, that's the data that we have. On the flip side, so we could write the data as a table, but we could also graph our data. That's the same data as the one in the previous page. Okay, so 19 to 23 years old. Have you heard of the word horizontal axis? Who's heard of that? Horizontal axis. Okay, maybe some. Vertical axis. Vertical. Okay. Horizontal is in the right, flat, and vertical means like the up and down. So on the horizontal axis here, horizontally, what's on the horizontal? These are the age, right? These are the age. And what's on the vertical axis? Yeah, number of students. So they said on the data, 19 to 23 years old, how many are in there? It says 55, right? 55 on your notes. So over here, this is 0, 10, 20, 30, 40, 50. So 55 would be up there, between 50 and 60. Okay, so the height of this, it's called the bar graph. The height of the bar graph tells us how many are in that category. Okay, so, and then here, as you can see, which is the biggest age group that we have in this picture? Which one is the biggest number of students? Like, which age group has the biggest number of students? 34 to 38. How do you know that? Because it's taller, right? So it's easier to do that. Whereas over here, right, you have to go every single one to figure that out, right? Visually, it's better. Okay, so this is called a histogram. Okay, now we're getting into reading graphs, interpolating and extrapolating. The word inter means in between. Okay, the word inter means in between the data that you have. Extrapolation means what's beyond, what's outside the data or graph. Okay, extrapolation is foreseeing what the trend is outside the given graph. Oh, I could use a pen. Yeah. Okay, so inter means in between, extra means outside. So the graphs, I'm just gonna continue on with this. Graphs are often used to show the trend over time. Oh, what's a trend? Oh, because somebody asked for a pen. Somebody. No, it's okay. I should know it already. Means in between the data. Okay? And extra means the outside. Datas, and graph. Outside the graph. Okay. So graphs are often used to show trends. What is a trend? What is a trend? Hmm? I can't hear you.
Something that's like in style.
A trend, a style? Okay, yeah, like a trend or style, yeah. That's another word for trend, yeah. Pattern, yeah. Pattern. Okay, what's happening? What's a pattern over time? Okay, is it increasing? Is it decreasing? Is it staying the same? What's the pattern? What's the trend? In many cases, some parts of the graph are easier to read than others. Yeah, I agree. Sometimes, yeah. Oh, well, don't worry about it for now. We'll look at some examples and we'll show you the pattern. Okay. Sometimes a question may require us to estimate. Estimate means we don't know the exact number, but we can approximate it. Estimate. Estimate. Okay. Reading between the given values is called interpolating. So between the given values, that's what interpolation means. Reading between the data or the graph. Extrapolation means other questions we might ask to predict values that might exist beyond the edge of our graph. Predicting graph values beyond the given information is called extrapolation. It's beyond or outside our graph. So here's an example. Okay, we'll talk about that right now. Just by looking at this, look at this graph. What is this about? What is this graph about? Population, okay. And how do you know it's about population? The title, okay. Title. What else? What else do you notice about the graph?
The years and the numbers.
The years, okay. So the years are along the bottom on the horizontal axis, right? The years.
The numbers.
Mm-hmm. And over here would be the population. So how many there are. So, okay, here's a if you take a look at this, what is the increment? What is this going up by?
15 years.
1967 to 82.
15 years.
15 years? Every 15 years? Okay. So when we actually create a graph, we have to have equal increments. It's going up by the same amount. Right? So this one here, 15 years, 15, 15, 15, 15. What about this one? What are they?
40,000. 40,000 or 4,000?
How many?
4,000.
4,000?
Yeah.
4 million. Yeah. They go up by millions, right? 4 million. They go up. Okay, can you see every single one are 4 million. So you're gonna hear me all the time when we create graphs. You have to have equal increments. That means it's going up by the same amount. Okay. Okay, I'm gonna use the word trend. Can you describe the trend? What's happening to the population?
Increasing.
Increasing? Yeah? How do you know it's increasing?
The line goes up. And the number is going up.
Okay. Did I have to teach you anything about that? No, right? Because you could actually, the picture, as you can see, it's increasing. Okay. So let's take a look at letter A. Answer letter A. what was the size of the Canada's population in 1987? 1987 would, where's 1987?
Not with the stated numbers.
1987 is here, right? 1987 is here, right? What we're gonna do,
27,000.
what's the population there?
27,000.
Okay.
7 million.
I think what we need to do is we need to invest in a really nice ruler. So if you have a ruler at home, make sure you bring it to school. So I have a ruler here. Can I go like this? Okay, I'm gonna draw it. Can I draw my graph like that?
Oh no.
No? Why not? Is that the right way? How do I do it? Straight. Well, that's pretty straight to me.
Straight upwards.
Oh, straight upwards, vertically. Yeah. Okay. Yeah. So. Okay, so it has to be straight up. Okay. Straight up. There you go. Is that pretty straight now? Yeah? Okay. Okay. So this particular point, okay, is it vertical, I meant? Yeah. So this, in 1987, the population is what? 27 million. Okay? So it's going to be 27 million. People. Okay? Next question. What was the population of Canada in 1992? Do you see 1992 in here? No? No, 1992. Well, where's 1992? Okay. 1992 is how many years? Yeah, it's in between 1987 and 2002, yes? Is it exactly in between?
No.
No? Okay. Closer to which one?
87.
87. Okay, here we go. We know that these two are how many years apart? 15 years apart. Yeah, 15 years apart. Okay, so 1992 is how many years apart from 1987? 5. So if we could count, if we divide this into 5 equal parts, so this is 5, that makes it 1992 there, right? Oh, shh. Yeah. Oh, yeah. Sorry. I really have to concentrate on this, and so 1992 I gotta do straight up.
That's,
Oh, that's not. The first
Oh,
one.
that's not. Yeah, you're right. See, I can't concentrate.
97 though.
Yeah, that's right, 1997. Yeah, exactly. So this is where it's kind of approximating. We can't figure it out exactly. So how many is that? What's the population there? So it's somewhere there 5 years after 1987, and now it's horizontally this way. Like that. Okay. So now you can see it's gonna be between 27 million and 31 million, and it's somewhere in between. So we can approximate that it's at about 29 million. 29 million. Is that okay? No, because 30 would be over here. a little closer to 31. Okay, what did we say? 29 million. Okay, though these two are called interpolation because it's in between the data that we have. Interpolation because of the information is within the data that we have in here, because we have data from 1867 to 2002-ish. Okay? Uh-huh. Yeah, this one here, we are approximating. We're approximating. Not exactly, but estimating. Are you talking about the 29 million? Yeah. So,
didn't get it.
you didn't, okay.
Yeah.
Here's what I'm gonna do. Here's what we're gonna do. Hmm. 20. Okay. When you look at the time, 1987 to 2002, right? That's what we see over here, right? It's just blown up. Okay. We know that this is 15 years apart, right? We have to approximate where is 1992. Where is 1992? Well, we know it's 1992 is in between these 2 years, but where is it? 1992 is 5 years from 1987. So if we know that this is 15 years, we can go 5, 10, 15. So this is 1992, 1997, 2002. So that means this is going to be a third of a way from 1987. So if we put this closely, 1987 to 2002, we're cutting it into 3 parts, to thirds every 5 years, and then 1992 is right here, the first number. So we draw vertically up, hit where the graph is, where the line is, and then do a horizontal, and then this is where your value is. And we know it's in between 27 million to 31 million. So it's going to be 29 million. So that's where the 29 million came from.
So I don't think it could be between 31 million and 25 million. Because let us try to found what can I say? Can I see that paper?
Oh, this paper?
Yeah, another one there. If we found that 1997.
Mm-hmm. If we do 1997, 1997 would be over here. Yeah, let's see if it's 1997 would be right here. So this is 1997, 2/3 of the way.
Yeah.
If I draw it up, I'll try to bring it closer. It's gonna be slightly above. So it's gonna be about 30. That would be the about 30 million.
Yeah, so that's all that 31 million is 15 years. I think between 1987
Mhm.
to 2002 is 15 years there.
Mm-hmm.
So
Oh, this
how-
is not it's
Yeah.
not straight. Okay, what is it?
Yeah, is 15 years.
Mhm.
So how now that's 1987 can be between 15 years? It doesn't make sense. Between can be 7 years and a half. That can be between.
Yeah, that's if it's that 50. Yeah. So what you're thinking about is this: 1987 and 2002.
Yeah.
Exactly in between, in the middle, is 7.5 years. So 7.5 years, okay? But when I say in between, it's not, I'm not saying exactly in the middle, because we said that from 1987 to 2002, that's 15 years. So what I could do is I can go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So, yeah, I could cut it into 15 equal parts, right? 15 years each time. And then 1987, right? 1988, 1999, 1990,
So
1991, 1992, which is 5 years from 1987.
Yeah, so in 15 years we have 4 million.
4 million?
In 15 years we have 4 million. So how could we in 5 years to have 2 million?
Oh, no, because the rate of increase is not the same each time. The rate of each year, it's not growing over here. The growth is not consistent each year. As you can, over here, the growth is slow, but then from here to here, the growth is so much bigger. Right. Maybe I'm not understanding your question.
Yeah, my question is was like the same because
if I understand correctly, you got it. That's good.
Come. Come. Oh, okay, sure.
we have 15 years.
Yes, yeah, okay.
So here it's 5 years. It's 10 years. So when you take this minus this, it's like 4. It's a 4 million. So this 5, how does it make sense? 5 years to have 2 million, and 10 years now 2 million too.
So it's not always the same.
It's almost the
they-
how now I should know this difference between how in
Just it's not
It's just
exactly.
to look.
Do you know? Not that one is not exactly perfect. That one.
how you know it's not exactly.
Just you come to mirrors that number. Not exactly that number. Between that one.
Oh, okay, I think,
He is thinking that is
I
exactly
think
perfect.
you know how I did. I took the difference between this and this, because this is 5 years. I make divide by 3.
Yeah.
The answer there. That I did.
good. Okay. What I can say is that we haven't talked about the rate of change yet. Yeah. The rate of change is different each single time. It's not the same rate here. It's not the same rate there. Yeah. So right now we're really not we're not figuring out the rate of change. What we're trying to do is we're just trying to read from the graph. So just relax. Okay. Okay, here we go.
And number C.
Letter C. We're gonna predict. We're gonna predict Canada's population in 2020. Well, where is 2020 here?
Way off the chart.
Out of the chart. Okay, it's called extrapolation. So, what we need to do is from here to here, we're gonna predict and assume, we're making an assumption. We're gonna make an assumption that it's gonna continue on. That the population still increases at the same rate. So where is 2020? So 2020 is 18 years from 2002. So 18 years. 5 years is about, how many centimeters is that? Once. So this is gonna be 17. So 2020 would be a little bit more, which is about 3 more years over here. We're extrapolating. It's way out. Okay, so 2002 to 2017, that's our next 15 years. So that takes us to 2017, and then 3 more years. So 3 more years, well, this is really a challenging one. So remember, each of these is 4 million. So if I go here, another 4 million. Okay. So we are approximating here. So if this is 35 million, so approximately that would be approximately 39 million. Yeah. So 39 million.
But there is 3 extra years,
Yeah. So yeah, we've taken that into account. So 15 years and then another 3 years.
Yeah, but what about in here? 4 million, and what about the 3 extra years? Maybe 1 million or 5,000, 5,000.
Right now we are not, it's not a consistent, okay? It's not 4 mil the way they had it here. Okay, I think I know what's happening in here. The increase of population is not 4 million a year.
Yeah, I know.
It's not 4 million a year. So here, you're just reading it off from there, up, vertically up, and then horizontal.
4 million in 15 years.
No, it's not. That's not true. Okay? Letter D. What assumption are we making in part C? Oh, oops, I didn't finish. What assumption are we making in part C? What assumption are we making here? So we're making assumption, assuming that the trend continues. That as time goes on, it's still going to continue to increase each time. The trend continues to increase. Okay. We're going to keep going. Take a look at example 2. Taking a look at example number 2. This one here, is kind of interesting. When we look at this graph here, it says here some information. What's on the horizontal axis? Months. Yeah. Horizontal axes are the months. What's on the vertical axis? Temperature, right. What's happening? What's the pattern here?
Going up.
What's a pattern here? What's happening to the temperature as time goes on, as months go on?
Going up.
I can't hear.
Going up and
I can't hear you.
By 10,
So,
it's going.
increase
Oh,
by
okay.
10.
Oh, this one is just the increments, right? Increments. What's happening to the graph itself? Yeah.
Oh.
What's happening to the graph? Yeah, as time goes on, the temperature increases, right? And then after that, the temperature falls down. And that's actually, this type of graph you will encounter in Applied 40. In Applied 40. This is a function. It's increasing, decreasing. And this is the season, right? Temperature is down right now. But then as summer comes, it gets hot. After the summer, it gets cold. And the cycle begins. Okay? So state, letter A, state the average temperature for August. So where is August? Okay, so January, February, March, April, May, June, July, August. So August, what's the temperature in August? Average.
14.
Oh, this is August is, it's gonna be somewhere close between 10 and 20. Okay, when I say between, it means not exactly in between, so somewhere around in the middle, or I wouldn't say middle because you would be upset.
Maybe 15.
Yeah, so where would that be? Is it 15? 15 would be in the middle of 10 and where would that be? So it would be here. Does that look like in the 15? No, it would be probably a little bit below 15. So is it 12? About 14, right? So state the average, it would be about 14 what? Degrees Celsius. Okay? Yes, quick question, sure. Okay, so if somebody says 15 degrees, yeah, I would say yes because we're approximating, okay? Right now, we don't have the actual function to describe this trend, so I would say 15 degrees. But if somebody says 22, no, that one doesn't make sense, so that's way too off. Okay, let's take a look at letter B. Determine the difference in average temperatures between July and January. Now, the word difference, what does it mean by difference? Your subtraction, you're comparing, right? Okay, what's the temperature in July? Now, July, that's the one that's 15, right? Okay, so 15. What's in January?
negative 12.
14.
Maybe 18.
Okay, because July is here.
Maybe 18.
So July is here. So it's, if this is 14, then that's about 15. Okay, so January, what's in January?
Negative 8.
Okay, -8. Oh, let's see. Huh? Is it -8? It's gonna be between -10 and -20.
Yeah, so maybe negative 12.
-13, 12? Okay. Okay, so, okay, if I put a middle in here, does that help?
Yes.
Okay, so is that more 12 or 13? Or 15? This middle would be 15, right? Negative 15, but this is slightly above 15. Negative, so that's going to be about negative 14. Okay, so negative 14. So what's the difference between these two? So the word difference means subtraction. So 15 minus negative 14. So that's 29 degrees Celsius. There's 29 degrees Celsius difference between January and July. Okay? It can't be 1 degree. Okay? That's too little. I think I'm gonna pause right here, and then tomorrow we'll oh no, are we? No, let's finish it off. Yeah, let's finish it off. So for how many months of the year is the average temperature above 0? Where's above 0? Okay, so above 0 is a positives, right? So how many months is that approximately above 0?
8. 7.
So is this above 0? It's below 0, right? Below April, that's above already, but then this one here, that's halfway between March and April. March and April is above 0. So half here, half a month. And then over here, there's also another half a month. So this is how many months is that all together? So it would be half a month here. 1, 2, 3, 4, 5, 6, 7. Because a half on each side. So it would be 7 months. 7 months that are above 0. Letter D. Predict the temperature for next February. So if this is this is 2019, what do you think the prediction is for next year in February 2020? Same what? Yeah, minus 10, because the cycle in this particular case is it's called a periodic function. The cycle continues, so it's approximately minus 10. Minus 10. Right? What are we assuming in part D? We're assuming that the cycle for temperature is the same every year. Okay? We're assuming that the cycle, the going up and down of temperature, is pretty much the same every year. Okay, so we did finish, and we don't have to continue on with that tomorrow. You do have some problem assignment 1 for you to work on your own. So please give this one a try. Try questions 1, 2, and question number 3 if you can. Okay?
There you go.